Hello and welcome back. Today we are going to look at graphing and writing equations of parabolas given a focus and directrix, much like we did last week, just adding on to what you already know. So as you did last week, please make sure you have a pencil and something to write on, either a scratch piece of paper somewhere in your notebook, or if you would like, the link to the PDF is right above this video and you can print it out and work with me. Please make sure before you continue with this video, you have already completed the activator, which is a review of what we worked on last week. All right, so today we're going to look at the standard form of a parabola. So if I give you the equation x squared minus 4x equals negative 12y minus 16, and I'm asking you to write it in standard form, you need to put it into one of the equations that we looked at last week. Then you are also being asked to identify the vertex, the focus, the directrix, and the axis of symmetry. Just by looking at this equation, I see that I have an x squared. So I know that I'm going to be using the formula. Let me go back there. X minus h quantity squared equals 4p times the quantity of y minus k. That's what we need to make our equation look like. So if you think back to when we looked at circles, there was something specific that we had to do. Hopefully, if you're thinking about it, you remember that it was called completing the square. So we need to complete the square in order to put this equation into standard form. However, the difference here is that with a parabola, you only need to complete the square on the left side of the equation. So to think about what we have, and there you go, only on the left side. I have x squared minus 4x. I know in order to complete the square, I need to take the b term, I need to divide by 2, and then square that quantity. So I have the 4 there, the negative 4. When I divide by 2, I have a negative 2. 2 squared is 4. So I'm going to add 4 to both the left side and the right side of the equation. You can see that in red. So now I'm left with x squared minus 4x plus 4 equals negative 12y minus 16 plus 4. So now I'm going to go ahead and simplify. I have a perfect square trinomial on the left side of my equation. So in order to factor that out, I'm going to simply ask myself, what number multiplied by itself will give me positive 4, but when added together gives me a negative 4? If you remember back to our circle equations, you would have the quantity of x minus 2 squared. Then on the right side, I'm going to simplify. So I'm left with negative 12y, and then I add negative 16 plus 4 because they are the like terms, and I'm left with negative 12. So my equation right now reads the quantity of x minus 2 squared equals negative 12y minus 12. The last step, the last thing that you need to do is to pull out the greatest common factor from the right side, because remember, we are trying to get the 4p value outside of the parentheses. So if you look at what we have, we can pull that negative 12 out of the expression that's on the right. So we will be left with the quantity of x minus 2 squared equals negative 12 multiplied by y plus 1. Because remember, negative 12y divided by negative 12, you're left with y, and negative 12 divided by 12, you're left with a positive 1. We now have an equation that matches our standard form equation, but we're only halfway done. Now that we have that equation, we can answer the rest of the questions. So, if now we know our standard form is x minus 2 squared equals negative 12 times y plus 1, I know that the vertex of this equation is going to be 2, negative 1. Because remember, my formula has a subtraction sign, x minus h squared equals 4p times y minus k. So I know that the y value has to be a negative 1 because minus a negative will give us the y plus 1 value. So my vertex is now at 2, negative 1. If I'm thinking about this parabola, I should realize that because my 4p value is equal to negative 12, I know that this equation has to open down. So if I were going to sketch it out, just to give myself a visual, Somewhere over here at about 2, -1, I'm going to have my focus. And I know this parabola is opening down because my 4p value is negative. So if I want to find the focus, remember the focus lies inside the arms of the parabola. So 4p equals -12. When I divide by 4, I get a p-value of 3. So I know I need to move 3 units down to get to the focus. So if I'm moving 3 units down, -1 minus 3 is -4. So my focus is going to be at 2, -4. To find the directrix, I have to take that p-value and move up from my vertex. So if I move 3 units up, I'm going to have a horizontal line. So by moving 3 units up, -1 plus 3 gives me a value of 2. So my directrix lies at y equals 2, because that's that horizontal line. Finally, my axis of symmetry, and remember that's the line, and I'm kind of drawing it or sketching it in, that's the line that goes right through my parabola, right through the vertex, because remember what happens on one side has to be reflected over to be on the other side of my parabola. So my axis of symmetry here will be x, because now it's a vertical line, and it's simply the x value of my vertex. So x equals 2. I have now completed this question by first putting the equation into standard form and then identifying the correct pieces of the parabola. The last thing I want to talk about today is when we're given certain information and we're asked to create possible equations. So given that the parabola's vertex is at -1, 3, and that the p-value is 3, we are being asked what are all the possible equations of the parabola. Now you need to think about the fact that we have parabolas that open up, down, right, and left. So if we're given a p-value that's positive, and we're given a vertex, then there are 2 possible outcomes for my parabola. The first outcome would be that it opens upward, and I would have the equation x minus h squared equals 4p times y minus k. However, that's not the only possibility, because you could have an equation that opens to the right or to the left. And in this case, it would be opening right because our p-value is positive. So again, we have the possibility of y minus k squared equals 4p times x minus h. Since we're not given any other conditions, then I need to make sure that I have both equations that are possibilities. So in order to do that, I'm simply going to take the values of the vertex, the -1 and the 3, and plug them in for h and k. I'm also going to take the p-value and plug it in where I would see p. So the 2 possible equations here are going to be x plus 1 quantity squared equals 12 times y minus 3, or y minus 3 quantity squared equals 12 times x plus 1. For this set of conditions, both of these equations will satisfy them. So when you're given certain parameters, based on the information you're given, you need to figure out what type of parabola you have and what the possible equations are going to be. Now it's your turn. So you're going to take the information you learned last week and the information that we just added, the completing the square and the given conditions, and you are going to click next in the module to go to the practice problems for this week. Good luck.